Hi, in this session we will look at determining the car prices in USA market using linear regression model. So first we load the required libraries as well as the dataset, and we look at the structure of this dataset, in which we see that there are a lot of categorical and numeric variables in the dataset, and as we know that to build a linear regression model we need to have only the numerical variables in the dataset. Subsequently we will see how we convert these categorical variables into numeric variables. Now next we look at the summary of the dataset, which gives us the various ranges of the numeric variables, and then we move on to the data cleaning and data preparation part, in which we check if there are any duplicates in the dataset, which is none, and then we look at if there are any NA values in the dataset, which is again none. Then we go on to remove the outliers in the dataset that we may have, and this is important because presence of outliers in the dataset may have a huge impact on the final model that we're gonna build. So with this we remove the outliers in the dataset, and then couple of other hygiene stuff where we go on fix the car price, car prices, car names, etc. And then we move on to create the dummy variables, convert the categorical variables into dummy variables, as we discussed earlier. And in this bunch of next steps we create the dummy variables. As we can see that now our final data set that we have contains only the numeric or the integer variables, and this is quite good now to basically it is quite we are ready now to build our linear regression model. Next we split the final data set into the training and the testing data set. The training is typically the 70% of the values, and testing is the remaining 30%. So we create this data sets. Then we go on to build the final first model using linear regression model using LM function. In this, as we can see, the dependent variable price is price is a dependent variable, and all other independent variables are used to determine the values of the dependent variable. So we get a first model in which we see that there are a lot of variables which are both significant as well as insignificant, and in order to reduce the time and effort we need to get rid of we use the step AIC function, which helps us get rid of the insignificant variables in our model. So we use the step AIC function, which uses both the forward and the backward selection methodologies to give us a trimmed data set. With this trimmed data set we build our model number 2, and we see again that the variables have both high and low p values, and we need to get rid of the variables which have high p values. In order to do so, we also have another parameter called a VIF, or the various inflation factor, which tells us that which are the variables that can be largely explained using other independent variables. So variables with high VIF values need to be removed. So in the next model that we build, we compare the we get rid of the fuel system 2BBL, as we can see here, and go on to build a model number 3, and then we look at the VIF for this model, and to basically we iterate this process until we have a variable set in which are all significant and which have low p values. So we go till model number 24 to get our final list of variables. Here we see that all the variables have very low p values, and their adjusted r squared value as well as r squared value is pretty good, and also the VIF says that none of the variables have too high VIF values. Next, using this model we go on to predict the final car prices using the testing data set, and then once we have that we go on to calculate the r squared value of the final r squared value of the car prices that we got using this model. As we can see, it is 83.6%, which means that it is 3.6% variance can be explained using the existing model, which means it is a fairly decent model, and hence we will consider this as a final output. And that's it for now. Thank you very much.